Hey, what is going on, guys, and welcome back. We are continuing with section 4 in chapter 2 on simple loops. This part of the section covers loops and helper variables. So we're going to do this reading, these two readings, and do these two exercises. I don't know why this is submitted already, but uh, again, as I mentioned in the previous video, sometimes this platform is a little wonky where some exercises look submitted, but they aren't. Other exercises have been submitted, but they get reset. So you just got to be careful. So let's do this reading and do the exercises. So this section is on loops and helper variables. It says, let's make the pin checking example a bit more realistic. So if you remember in the previous video in the reading, we did, where was it? This one. This was the example that they're talking about. So you can go back up there and take a look at it. This version gives the user only 3 attempts at typing in a pin. The program uses 2 helper variables. The variable attempts keeps track of how many times the user has typed in a pin. The variable success is set to either true or false based on whether the user is successful in signing in. So here we have a helper variable called attempts and another helper variable here called success. So we have attempts is equal to 0. Then we have a while true loop. We ask the user to input their PIN number. We increment attempts by 1. Then we check if the inputted code is equal to 1, 2, 3, 4. If it is, set success to true and break out of the loop. Alternatively, if the number of attempts is equal to 3, set success equal to false and also break. So we know that if we've done it 3 times and we haven't encountered this condition, right? If this condition hasn't been satisfied, then that means this time, when it's the 3rd attempt, there's no way it's going to be the right pin number. So we set success to false and then we break out. Otherwise, we print this. So if neither one of these conditions hasn't been satisfied, then we print incorrect to try again. Then outside of the while loop we have here, we check if the pin number, if we break out of this loop because the code entered was the right code and we have a success Boolean value, then we print correct pin entered. Otherwise, we print too many attempts. So this is the program when it's running. Please type in your pin. We type in 0000, incorrect, try again. We type in 1, 2, 3, 4, correct pin entered. Here we have some more attempts, 000, incorrect, 999, incorrect, 4321, too many attempts. And we get booted out of the loop. The loop is exited either when the user types the correct pin or if there have been too many attempts, like a real ATM would. The if statement after the loop checks the value of the variable success and prints out a message accordingly. Debugging print statements in loops. Adding loops to programs also adds to the potential sources of bugs. It becomes even more important to master the use of debugging print statements as introduced in the first section of this part. Let's have a look at a program almost identical to the previous example, but with one crucial difference. So again, we're keeping track of our attempts. The code does the exact same thing, asks us for a pin number, we increment the number of attempts, but as you can see, we have inverted the order of the conditional checks. So it first checks whether or not we've hit 3 attempts, and then we break out of the loop. And then it checks if we've entered the right pin code, and then it breaks out of the loop if that condition is satisfied. Otherwise, it prints incorrect, try again. Then we have the print statements again here that are printed depending on if the pin code was successful or if we've exceeded the amount of attempts. This version acts strangely when the user types in the correct code on the 3rd attempt. It says, please type in your pin, 000, incorrect, try again. Please type in your pin, 999, incorrect. Then when we type in the correct pin code of 1, 2, 3, 4, we still get this message of too many attempts. So what gives? It says, let's try and find the cause. Well, we've already discovered the cause, but I didn't really talk too much about it. But I'm going to let the material, kill the suspense. So let's try and find the cause by adding some strategic debugging print statements inside the loop. So we added this print statement that prints when we're at the top of the loop. Then we print the number of attempts, and then we print if we have exceeded the condition or if we have met the condition that we are at 3 attempts. Then it does our if statement like before. Then it prints what pin number we entered. Then it checks if the pin code that we have entered matches the correct pin code. If it is, then we break out. Otherwise, we print incorrect, try again, and then the loop goes on and on and on. So this is how the code will look. Please type in your pin. So it's first going to tell us that we're at the top of the loop. Then we're going to enter our pin. It's going to increment a number of attempts. It's going to check if attempts is equal to 3. It's not, so it returns false. Then it's going to print out the code that we entered, 2233. It's going to check if 2233 is equal to 1234. It's not, so the condition hasn't been met, so it prints false. Then we get met with the incorrect try again statement, print statement. And it does that over and over until we reach our third attempt. So we're at the top of the block again. We type in the correct pin code. It checks that the attempts has reached 3. And so that means that we've met this condition right here. Attempts is equal to 3, so we break out of the loops, printing there's been too many attempts. From the above printfs, we can see that during the third iteration of the loop, the condition of the first if statement is true and the loop is exited. So we've basically sees that we've reached the number of attempts allowed and it breaks out of the loop. This iteration never gets to the second if statement, which checks whether the code was typed in correctly, right? This one. The order of the conditional statements or of different branches within a conditional statement is a common cause for bugs, especially in loops. Debugging print statements are often the simplest way of finding their cause. So that's just something to be careful inside loops. If you're having conditional checks, just make sure that the order that you have them in makes sense. Otherwise, you might end up breaking out of your loop before or after what you're supposed to be doing. So if you're supposed to break out after you reach a successful attempt, then you should check this before we check whether or not we've exceeded the amount of attempts allowed. Okay, so here's our first exercise. It says, please write a program called pin and number of attempts. It says, please write a program which keeps asking the user for a pin code until they type in the correct one, which is 4321. The program should then print out the number of times the user tried different codes. So, as for the pin, 3245, we print wrong. 1234 prints wrong. 000 prints wrong. When we type in 4321, it says correct. It took you 4 attempts. If the user gets it right on the first try, the program should print out something a bit different. So if we type in 4321, correct, it only took you 1 single attempt. So we know we have to keep track of our attempts, so we'll set that equal to 0. Then we know at the end here we have to print out 2 statements that depending on the number of attempts. So if our attempts is greater than 1, then we print correct, it took you the number of attempts. If we succeed in the first attempt, then we print correct, it only took you 1 single attempt. So this is completely separate. So we could do if attempts is equal to 0, then we want to print correct, it only took you 1 single attempt. Else, print, we're going to use F strings, correct, it took you attempts. Okay, now let's do our loop. So while true, we're going to prompt the user for a pin. Pin is equal to this integer inputted value. We're going to increment attempts. Then we're going to see if if pin is equal to 4321. There's a colon here, we want to break. Otherwise, we're just going to print wrong. So let's run this. Invalid on number 12. Oh, it's supposed to be 2 equals. So if we type in 3245, it says wrong, asks us for the pin again. If we type in 1234, wrong. If we type in 000, wrong. If we type in 4321, correct. It took you 4 attempts. We spelled attempts here wrong. And then if we do it on the first try, correct. It took you. Okay. Break if attempts equals, this should be equals 1, not equals 0. 4321, correct. It took you 1 single attempt. And if we test this, we're good to go. We can also view the model solution. And same thing. So they set attempts to 1. And then they do pin. If pin is 4321, break. Otherwise, print that it's wrong. And then increment attempts. We set attempts equal to 0. And then the first time the loop runs, we increment attempts by 1. And then we check if the pin is entered is correct. If it is, break out. Otherwise, print wrong. And then loop again. And then if we only did it in 1 attempt, we print this specific string. Anything greater than that, we print this specific string. All right, awesome. So let's do the next exercise. This one is called the next leap year. It says, please write a program which asks the user for a year and prints out the next leap year. So if we plug in 2023, it says the next leap year after 2023 is 2024. If the user inputs a year which is a leap year, such as 2024, the program should print out the following leap year. So if we enter 2024, it says the next leap year is 2020. After 2024 is 2028. So if you remember, in a few exercises ago, in section 2, part 2, we did an exercise about leap years, which was part of the learning material on nested conditionals. So if you go to the GitHub repository, click on the part 2 folder, exercise 12 is the one about leap years, and I gave you guys 2 different solutions. You can find if a given leap year is a leap year by doing it this way, by nesting conditionals, or by doing it like this. So when I was reading through this exercise earlier, I remembered that, hey, we did something that helped us figure out if given the year is leap year or not. So that might end up being useful to us. So we're gonna use this. So I'm gonna copy this. I'm gonna use this one. You could use this one if you want, but it just kind of gets messy. I can see it getting kind of messy, having to plug in your helper variables deeper and deeper, and writing a break statement here and here and here and here. I think this one's a little bit easier for us, so I'm just gonna copy that. So we're gonna have to have a variable here that keeps track of our given year. So integer input year. Then we're gonna have a helper variable here called next year, which is gonna be set to year plus 1. Then we're gonna have a loop, and we're gonna just have our print statement here. Our if statement here, our conditional, saying, hey, if next year. Also, another trick, if you double click on any variable or word in your code that you want to change all at once, you just hold Alt, you hold Alt, then you double click. While holding Alt, you keep double clicking, and it will highlight all 3 instances, and then you can just change them like that. So here we just want, if we have a leap year, we just want to break. Not going to do anything else. That's all we want to do. Then here we're just going to print exited. Let's run this. So if we plug in 2023, exit. Plug in 2024, exit. It's going to keep running forever because it's a leap year. Okay, so we also want to increment year by 1 in the event that next year is not a leap, the given year. If the leap year that we have, right, if we've gone through this and Python determined that the given year, the year is not a leap year, then we want to come and do here and increment it 1 more time and then let the loop run over again until we find a leap year. If we do have a leap year, then we want to print, we'll use an F string here, print the next leap year after year is next year. So let's run this. Plug in 2023, the next leap year after 2023 is 2024. Plug in 2024. Okay, we're getting an infinite loop here. Let me take a look at my code for a second. Okay, I see the problem why we're running into an infinite loop when we type in 2024. Is right here. Same issue that I mentioned in a previous video. So when we first set our year, then we have our help available next year, which is equal to the inputted year plus 1. Then we check if the next year is a leap year or not. If it is, we break out of the code and we print when we come down here. Otherwise, we want to increment next year by 1. But what I'm doing is I'm actually just repeating this down here. So because year is always going to be whatever is the first input that we provide here, for example, 2024, that means next year is always going to be 2025. It's going to keep doing 2025 over and over and over and over again because I'm not properly incrementing the next year variable here. So I need to change this from year to next underscore year plus 1. Now if you run this 2024, there we go, we get 2028. If you plug in 2026, we get 2028. If you plug in, let's say 2028, it's going to say 2032. So now this code works. So that was just my not paying attention because I just copied and pasted this line down here. But yeah, next year needs to increment by 1 inside of our loop so that we can check the next year and the year after that until we get to the correct year that is a leap year. And then that way it's going to break out of our loop and then it's going to print the next leap year after 2028 is 2032. So this is the solution to this. Let's give it a test. And there we go. Let's see the model solution. So here they have a variable called start year, and then year is equal to start year plus 1, which is similar to what we did, just inverted. Then they have a while loop here, and they check. So they use this solution, right? Check if the remainder from year divided by 100 is equal to 0. Then check if that year divided by 400 also returns 0. Then we break. Otherwise, and if the year is also divisible by 4, then we also break. If not, we increment year by 1, and then the loop goes on until it finds a leap year, and then it comes out and prints. So you could do it that way, or you could do it this way. This is a little bit more shorthand, but this is also a very good solution because it goes back and plays into working with nested conditionals. So either solution works. You could have copied this. Basically, you could have copied this right here and plugged it in over here. Replace the print statements with the correct break statements that you want, and then at the bottom have next year is equal to next year plus 1. So yeah, so that's the solution to these 2 exercises. I'm going to leave this reading and the final 2 exercises for the next video. Hope you guys enjoyed it. If you have any questions, make sure you ask them in the comments below. Again, you can find this code if you want to use this code or this code in your solutions. It's up on the GitHub repository. You could also check your own solutions. If you're saving them somewhere, you should be able to find it. But that's very interesting. Sometimes they might ask us to look back in our previous exercises and use some of the material from there to be able to solve new exercises. So thank you for watching, and I will see you guys in the next video where we'll get to finish section 4 of part 2 and move on to part 3 down the line.